Hello and welcome! In this lecture we're going to learn about C# interfaces and use them to make our interaction code work with any object we want. Okay, so here's our game. We've got a door here. I can walk up next to it. I can use interact action and interact with the door. So it works. I can either open or close it. Okay, so the interaction is all working perfectly. However, here we're working with a specific type door. What if, for example, now we want to build a treasure chest or maybe a simple button? For that, based on how we wrote the code, we would need to test for more and more types. Meaning that we would need to add all of those types on the validation logic and also on the grid object. So that would lead to quite a lot of code duplication. That's not a very scalable approach. So let's instead refactor our code to be quite a bit more generic. For testing, let's make another simple interactable object. So let's create a brand new game object. Call this the interact sphere. And then inside, let's create a new 3D object, a new 3D sphere. Let's put it just a bit smaller, just like that. Again, doesn't really matter. This is just for testing. So over here, let's get rid of the spherical letter. Okay, so we got just a basic sphere. Let's actually put it on a Y of 0 and lift it up by a bit, by about 1 unit. Okay, so here we've got a simple sphere. Let's put it on this grid position. So 8, 0, 4. All right, now when we interact with this sphere, we really want to change the color. So let's make two materials for it. So let's create a brand new material. Let's make this green. Another one, just call it red. Then on both these, let's just make just with a bit of nice emission. So let's go into the sphere. Let's attach this. Again, we're making this just so we have a nice visual. So with quite a bit of emission. Okay, so that's the red material. And now for the green. So just go here, enable the emission, make it into a nice green. For the emission, also a nice green with lots of glow. All right, so you've got two materials that you want to swap. Now let's make a script to run this. So let's go into our scripts, create a brand new C# script for the interact sphere. Let's attach the script and let's open. Now here, let's make two simple functions to change the material. So private void set color green and a private void set color red. Okay, now let's make serialized fields for the materials. So for the green material, and another one for the red material. Then we just need to grab the mesh renderer for this sphere. And let's also make this a serialized field since this one is a child and not placed directly on this parent. Then on private void start, on start, let's just call one of them. So let's say set color green. Then we also need to keep track of which one we have. So private bool is green. Then here, let's set is green to true. On the red is green to false. And over here, we just set the mesh renderer into the green material. So that's that one dot material. And then same thing for this one for the red material. Okay, so that's it. Some very simple logic, just changing the material on the mesh renderer. So let's just assign these fields. Here in the editor, first of all, the mesh render that's inside the sphere. Then for the material, so the green material, find the red, that's it, down. Okay, right. So now we have this simple script. And then we also have the door script that we made a while ago. And for this one, we called the interact function, just called it interact. So we want to use the exact same function to interact with either a door or a sphere. So let's refactor our code to make this function more generic. And in order to make that happen, we're going to be using a C# interface. And since this is the first time we're using an interface in this course, let me briefly explain what they do. Basically, an interface is a contract. An interface defines some function signatures, and when you define a class to implement a certain interface, then you are required to implement those functions. Then instead of having your code work directly with a specific type, you can make it work with just the interface, and you can access the interface functions. It's actually quite similar to the abstract function that we used previously in the base action. So if you understood those, then this is going to be super easy to understand. Let's see it in practice. So here in the editor, let's first make our interface. So create a new C# script, call it IInteractable. Now usually the naming convention for interface is to start with I, so that is why IInteractable. Now let's open. And over here, this does not implement mono behavior, and we do not have these functions. And also, this is not a class. So instead of class, this is a public interface. So now here we define the function signatures for whatever functions we want. And like I said, it's similar to what we defined on the base action. So if you remember over here, we've got some abstract functions. So it's pretty much the same thing that we have to do. One main difference is by default, all interface functions, they have to be public since they have to be implemented. So over here on the IInteractable, you normally don't define the accessor. So you just define the return type. So let's say void, then the function name. So let's say interact, and then any parameters you want. Like I said, the goal is to make a common interface that is shared between all interactable objects. So what we want is to force every object to implement this interact function. So let's go with this signature, void interact. Then let's use our action callback. So let's add using system, use the action callback and call it the same thing. So on interaction complete. Okay, so that's it. This is all we need in order to define our interface. Now we can go into our door script, and over here we have the door. We extend mono behavior. Okay. Then afterwards, let's just add a comma and let's implement our IInteractable interface. And if that's it, we don't need to do anything else. As you can see, there are no errors. And the reason for that is because we already made a function with exactly that signature. So we already have a private void interact with our action. So there's nothing else we need to do in this script. Now let's go into the interact sphere script. And over here, let's do the same thing. So we extend mono behavior and then implement IInteractable. And now we do see the error. Like I said, an interface is like a contract. So if you implement the interface, then you must implement all of the functions in the interface. So it's here telling us that we need to implement the interface member for the interact function. So let's do that. We can use the light bulb to implement the interface. And there you go, down here it creates a interact function. And then here, let's just call our symbol function. So let's test if is green. So if it is green, then set the color to red. And if not, then let's set the color back into green. Okay, so that's our super simple interaction. Now here, like we did on door, we implemented a simple timer. So let's do that, the same thing here. So we just need to store the interaction complete. So let's store all of these. So let's do exactly the same thing we did on door. So we can copy all of this. Again, just to make sure that the action isn't 100% instant. So on the update, we just do the timer. So let's go up here onto the update. So we check the active, count on the timer, and call the callback. Let's just change the name, which by the way, you don't need to use the exact same parameter name. That is why here we're actually using onInteractionComplete, which is what we defined on the interface, but on the door, we called it onInteractComplete, and this still works. All that matters is the type, so the name doesn't have to perfectly match the interface, but still we should probably match it. So let's copy this. Let's rename this one into the same thing. So onInteractionComplete, and same thing for this one, just copy the same name. Okay, great. So everything is working. There are no errors on any of these two. Now finally, let's go into the interact action. And over here for the validate, we were doing this. So we ask the level grid to get a door, and then we interact directly with that door. But of course, this only works with the door, so this is not going to work with our sphere. So instead of working directly with the door type, let's work with the IInteractable type. So interactable. Then over here, if interactable is null, then no interactable on this grid position. So that's how we define those. And then down here on the take action, instead of grabbing a door, let's grab of type IInteractable, and then we call the exact same function. So this is working. There are no errors because the function to get the door automatically converts the door into IInteractable. But let's obviously refactor this in order to get an IInteractable directly on the grid objects. So let's go here, instead of door, make it IInteractable, interactable. Then down here, let's rename all of this. So instead of get door, this is going to be get interactable. IInteractable for set interactable, and over here for get interactable, and we return IInteractable. All right, and also on the level grid, so let's rename this. So get IInteractable for the set interactable, for these interactable, and so on. Let's just rename all of these, so the interactable and so on. For the get interactable at this grid position, get interactable at this grid position, returns IInteractable. Okay, so we renamed everything. Then also let's go on to the interact action. So this is get interactable at this grid position. Down here, get interactable at this grid position. Then also on the door, over here when we are setting, instead of set door, so set interactable. And finally, we also need to add this logic onto the interact sphere in order to know where it is on the grid position. So let's do that. We just need to store private grid position for the grid position. All right, so everything was sorted. So the grid object now instead of a door works with a IInteractable. The level grid, the same thing, and interact action over here, the same thing. So it takes an action, asks the level grid to get an object of that type, and then just calls interact on that type. So here we can see the true power of interfaces. Basically, when we ask the level grid for an interactable object, over here we have no idea if the object that we get, if this is a door or if it's a sphere, a button, or anything else. All we know is that this object guaranteed for certain that implements this interface, and since it does, then we know for certain we can call this function. So even if we made 1,000 interactable objects, we would not need to change this code ever again. So with this, we can just test. So here we are, we have our objects. So if we approach a door, we use interact and we interact with it. Yep, open and close door. All right, works perfect. And the other one, it's also saying that it's an interactable position. And if I click on it, yep, there you go, turns red, click, turns green. All right, awesome. So we can interact with either of these objects and everything works perfectly. So as you can see, this is the power of interface. You can make your code work with all kinds of objects thanks to the level of abstraction that the interface provides. And also before we end this lecture, let me just point out one thing. Since over here you'll learn about interfaces, you can imagine how you can also apply the exact same logic over here to the destructible objects. When we made this, we made a specific type called the destructible crate. So we made that the grenade checks for that type and destroys it and calls a destroy function on the object. But you can refactor that code to make a destructible interface and easily create all kinds of destructible objects. So as you can see, interfaces are extremely powerful. Alright, so here you'll learn about C# interfaces, and we made our code work with a generic interactable interface. With this system we can create all kinds of interactable objects super easily. We can make doors, buttons, chests, lasers, or literally anything you can think of, and because of using an interface it is super easy to do.